Hello, this is John from caveofprogramming.com, and this is a second tutorial in the series on multi-threading in Java from Cave of Programming. So in the first tutorial we saw how to start threads in Java, and in this tutorial we're going to start to look at basic thread synchronization. Now there are two problems that you encounter if you have more than one thread sharing the same data. Two kinds of problems, and the first one we're going to look at in this tutorial, and it has to do with data being cached, and the second kind of problem, which is more vicious, has to do with threads interleaving, and we're going to look at that in the next tutorial. But here I'm going to show you the purpose of the volatile keyword in Java, and we're going to look at some very basic thread synchronization. So I'm in Eclipse here, and I've created a project, and I've created a class for the main method, and I'm going to create another class here which I'll call let's call it processor, and I'll say that processor extends thread, and the idea is that processor is going to run some code in its own thread. So I'll give this a public void run method, and here I'm actually overriding the public void run method in the thread class, so I can put some code in here that I want to run, and I'm going to start off actually with just an infinite loop here. So I'll say while true, and in this loop I'll do a sysout and say hello so we can see something happening, and then I'll make it pause for 1/10 of a second before going around the loop again. So I'll use the thread.sleep method that we saw in the last tutorial, and I'll make this pause for 1/10 of a second, 100 milliseconds, and I've just got to handle the exception there. Now I can run that code in its own thread by saying processor, here we go, I'll call it proc1 equals new processor, and now I'll say proc1 dot start, and start will tell the thread class to run the code in the run method in its own thread. So if I run this now, we're just going to see hello coming out every 1/10 of a second. Now the problem comes when you start thinking about how you could terminate the processor gracefully, and one way to do it would be to use thread interruptions, and we're going to look at those in further on in this series of tutorials. But here I want to show you an example of using some shared data. So I'm going to create a variable here. I'll make it a private variable of the type boolean, and I'll call this shutdown, and I'll say shutdown equals false to start with, and I'm going to say while let's call it running on second thoughts, and let's make it true to start with, and I'm going to say while running do the loop, and I'm going to give this a method called shutdown, so I'll call it public void shutdown, and I'm going to say in shutdown that running equals false, and in my main program here I want to have some way of pausing until I call the shutdown method, until I want to call it. So to do that I'll just create a scanner here equals new scanner, and scanner is just a class that can scan input streams, and I'm going to just use it here to detect a new line in the system.in input stream. So I'm going to say scanner.next line, and that will just pause execution of my main thread, my main program here, until I hit the return key basically in the console. And when I hit the return key, in fact let's have a prompt here. Let's say sysout press return to stop. When I hit the return key, I'm just going to call proc1.shutdown. Now let's see what happens when I run that. So I'll run this, and it's merrily saying hello, and I'll hit the return key, and it has stopped, and if I run it again, hit the return key, again it stopped. And in fact, I must confess, I've never seen this kind of setup not work. But here's the catch, because apparently under some conditions, or on some systems, or maybe, I don't know, with some implementations of Java, this thread here, the thread that's running this code, might decide to cache this value at the start, so that it will never see the changed value of it. And the reason for that is that we've basically got two threads here. This main program has its own thread, and I'm kind of spawning off another thread when I call start here, and I'm running this code in a different thread to the main thread. So we've got two threads running here, and both threads are accessing the same variable. So this thread here is reading running. Every time it goes around the loop, in theory, it should check the running variable. And this thread here is writing to running, because when it calls shutdown, it's calling shutdown in the main thread, and that's then going into this method and calling setting running to false in the main thread. But the problem is that when Java tries to optimize code, one single thread kind of doesn't expect other threads to modify its data. So this code here, this thread here, has its own copy of running, and it's not expecting other threads to modify it. I mean, I guess it's not strictly speaking true to say that it has its own copy of running. There's only one running, but nevertheless this thread might look at what's going on in this thread alone and say, okay, I never actually changed the value of running, I never set it to true, because shutdown isn't called in this thread here. So running never changes in this thread, and it's going to say, okay, in that case I'm going to optimize. I'm not going to bother checking the value of running every time I go around the while loop. I'm just going to assume that running will always be true, and I'll keep going forever. And in theory that could happen on some systems. So to prevent that happening, you use the volatile keyword, and I can say private volatile boolean running equals true. And in this case it has no discernible effect, the program still works, but the difference is that now this code is guaranteed to work on all systems, on all implementations of Java, and there's no chance of me calling shutdown and of the new value of running being ignored by this thread. So that's what volatile is used for. It's used to prevent threads caching variables when they're not changed from within that thread. And if you want to change a variable from another thread, you either have to use volatile, make it volatile, or, as we'll see in the next tutorial, you have to use some kind of thread synchronization. So that's it for this tutorial, and this is pretty simple, and this is just a technique that you can use if you want to shut down a thread or multiple threads gracefully from another thread. In the next tutorial we're going to get on to looking at the slightly thornier problem of threads interleaving, and we're going to look at what can actually go wrong there. And unlike with this particular case, caching variables, it's very easy to demonstrate things going wrong with when you're reading and writing integers from multiple threads, for example. So we'll look at that in the next tutorial. So join me again then, and you can find this code on caveofprogramming.com, and you can also find there links to more complete tutorial series. So check those out if you will. And until next time, happy coding.